mathematicians, I'm recording a very quick video here to show you literally how to calculate a vector product, also known as a cross product, which is very awesome and very useful. When we work with vectors, we'll see the number one most beautiful thing is that the cross product will result in a vector, and that is perpendicular to both of these two vectors, which is totally rad. So let's see how to do this. Now, there's a couple of methods, but one of them that I love very quickly is based on remembering these numbers. The numbers would be 23, 32, 31, 13, and 12, 21. Now, what the heck are we going to remember those numbers? 23, 32, 31, 13, 12, 21. Because that's one way to help us remember how to find this vector product. It tells us which elements that get multiplied together and then subtracted to form this vector here. So the way it works is that in a vector product, you're going to multiply certain of these together and subtract them, and it comes up with a new vector. So it's always going to be an A times a B minus an A times a B. An A times a B minus an A times a B, and A times a B minus an A times a B. Now, which A's and which B's? Well, it's always going to be in with the second element A times the third element in B minus the third element in B times the second element in A. In other words, it will be A2 B3 minus A3 B2. So if I wrote those down. Now, of course, what do I mean by them? We could call this element 1, 2, 3, element 1, 2, 3, and we can calculate across like that. Sorry, it's a little tiny. Hopefully you can see that. Then, after that, we'll start with A3 times B1 minus A1 times B3. So let me label those, right? And then finally, we'll have A1 times B2 minus A2 times B1. And there's a couple different patterns you can hear in even remembering these numbers, but this is one way. I've had plenty of students who just sort of memorize this pattern: 23 minus 32, 31 minus 13, 12 minus 21, and that'll help them get this. So let's get a quick example to see that. Say we had just a vector that was 1, 2, 3. Let's see, let's cross that with, I don't know, 4, 5, 6. How creative are we? Well, then that resulting vector product would be a vector that is 2, 3 minus 3, 2. So let me number these. 1, 2, 3, 1, 2, 3. So that'd be 2 times 3. So that'd be 2 times 6 minus 3 times 5, right? Which would be 12 minus 15, which is negative 3, right? And then I would do 3 times 1, so 3 times 4, which is 3 times 4. I'll write that out. 3 times 4 minus 1 times 6. So that would be 12 minus 6, which is 6, right? And then we'll have 1 times 2, so 1 times 5 times 2 times minus 2 times 4, so that would be 5. That would be negative 3 right there. All right, so there you go. That's the vector product. Now, one of the cool things about that is that this vector here, this resulting vector, right, is going to be orthogonal, or also known as, I was misspelling orthogonal. That's so sad. Orthogonal. Which is also means perpendicular to either of these two original vectors. And we could check that by doing the dot product. Now, this would also help us remember what the dot product is. So if I did 1, 2, 3, right, dot, say, negative 3, 6, negative 3, then that should come out to 0 if they are, in fact, orthogonal. So let's check. To do the dot product, we would have just multiplied across. 1 times negative 3, and it's a scalar product, so we just get a number here. So 1 times negative 3 is negative 3, and we'll add to that 2 times 6, which is 12, and then we'll add to that 3 times negative 3, which would be negative 9, and when you do the math, you get 0, right? That justifies to say that this vector here, 1, 2, 3, is orthogonal to negative 3, 6, negative 3. So that's kind of neat and nifty, right? Now, there's another way of finding a cross product, and if you studied matrices, that could be very useful to you. It's some people call it the determinant method or something like that, right? And so if I could take my two vectors and I could write them in component form using the unit vectors I, j, k. Horizontally, I can create a 3 by 3 matrix. Like, so if I imagined I had a matrix that was I, j, k, right, as one row, and so the I for my first vector would be 1, right? The j would be 2, and the k would be 3, if I was to write it like that. And then for my second vector, 4, 5, 6, this would be 4, 5, and 6, right? So if I had this vector and I was to find the determinant of this vector, or, excuse me, if I had this matrix and I was going to find the determinant of this matrix, then the determinant method says, okay, you're going to do this sort of cross this diagonal multiplication. And for your first component, right, what you would do is you would say, ignore the first column, and then do a little, focus on this little square here. So you do it from left to right, and top left to bottom right, multiply, and then subtract the bottom left to the top right. In other words, it would be 2 times 6, which is 12, minus 5 times 3, which is 15. And notice that was, once again, negative 3 in the first component that we had here, right? Now, we, oops, that doesn't help if I erase the terms. I should have written those in black. What was that? That was 4. Now, for the next middle term, you would ignore the center now, right? And you would look at the resulting, right? The center column. So if we cross this guy out, then now you would look at 1 and 6 and 4 and 3. But the order of the subtraction changes. Now you would do 4 times 3, which is 12. And then you would do 1 times 6, which is 6, so 12 minus 6. And so that is 6. Right? And then for the last one, you would ignore just the last column, and then you look at this square here, and once again, you go from left to right. So that would be 1 times 5, which is 5, minus 4 times 2, which is 8, and you get the same resulting vector, negative 3, 6, 3. This method is kind of nice, especially if you have experience with matrices. My students who are watching this technically haven't really studied matrices thematically, so you don't really know about determinants, you don't really know this method, and so me showing you this, maybe it helped, maybe it didn't. Though I've actually found, at least I used to have kids always use this matrix method, but I found a lot of kids really just do well remembering this little pattern. 23, 32, 31, 13, 12, 21. And see if there's reason that you can memorize those numbers. I mean, just like memorizing pi, 3.1415926535897993223832 I don't know. After that, I forget. I have to do some work memorizing pi again. But you can memorize these little couples of numbers. Clearly 23 and then gets flipped 32, 31 gets flipped 13, and 12 gets flipped 21. You can memorize that, and I think that's just as good a method as any to find the cross product. So anyway, that's what that's how you do it. What it does is it comes up with these orthogonal vectors. Have a beautiful day. Hope this was useful to you. Adios.